Hello, Math 12 students. Today we're going to finish 7.2, Part 3. We only have two more things to talk about and we'll be done. We're going to talk about inverse functions. And we're going to talk about rewriting the sum of sine and cosine as a single function. So you can kind of consider these applications of the sum and difference formulas. In the very loose sense of the word applications, we're not going to solve any, real-world engineering or physics problems or anything like that. These are still just abstract math problems, but they're in the realm of applications of what we've been talking about over the last couple of days. Let's start off with inverse functions. We haven't done much with them so far, so suppose I wanted to simplify cosine of sine inverse of x plus cosine inverse of y. Let's do a brief review of the sine inverse and the cosine inverse before I actually do any of the problems. An inverse function is actually an angle. So the way you read this, so just the inverse function, you would read it in a very specific way. You would read this as what angle theta has sine, or is, I should say, is sine theta equal to x. So the inverse function, the inverse trig function, is asking a question. It's saying, what angle has a sine of x? Similarly over here, cosine inverse, you would read, what angle... I better not use the same symbol as this one, because this is an x and this is a y, and they're different. So let's call this one phi. If you're not used to that symbol, that's phi. It looks like phi. Some of the sororities and fraternities at the university actually call it phi. And in math, we like to make fun of them and say, well, you're actually saying it wrong. It's phi. It's more like phi, phi, pho, fum. So what angle phi is, but I digress, cosine of phi equal to y. So we draw a reference triangle for each of these angles. Let's get back over here to the x. So sine inverse is equal to x. Sine inverse of x means that the sine of this angle is x. So that means this side of the triangle is x. This side of the triangle is 1. Okay, that's what it means to say that sine of theta is equal to x. We're going to need all three sides of the triangle. So this side is going to be 1 minus x squared under the square root. Just use the Pythagorean theorem. I'll leave that as an exercise. Just a squared plus b squared equals c squared, and you'll find out very quickly where I got that from. Over here in my cosine, it says, what angle is cosine equal to y? It's interesting that I'm putting y on the horizontal side of this triangle. It's not traditionally y, and similarly over here x, but the letters x and y are just arbitrary variables. They don't necessarily mean what they meant in basic algebra. Similarly, if you use the Pythagorean theorem, you'll get this side of the triangle is also the same as that, just with a different letter. It's going to be the square root of 1 minus y squared. Again, use the Pythagorean theorem. Okay, so that's just kind of the setup. I haven't actually done the cosine yet. So let's go ahead and do this problem. So now we have cosine of sine inverse of x plus cosine inverse of y. Sine inverse is theta and cosine inverse is phi. Yeah, this is a substitute. So now I'm going to use my sum formula. That's going to be cosine theta, cosine phi, minus sine theta, sine phi. It's the sum formula for cosine. Now look down here at these triangles. These are your reference triangles. We know that cosine of phi is y. Yeah, so what is sine of phi? Just look at this triangle. That would be the square root of 1 minus y squared. Just looking at this triangle. The sine is the opposite over the hypotenuse. Since it's over 1, I'm not going to write it. If you really want, you could put over 1, and you could put, y over 1 like that, just if it makes it clear to you. Similarly, over here, I've got sine of theta is x. So what is cosine of theta? Look at this triangle. It would be square root of 1 minus x squared. And again, if you really insist, you can write both of these as trig ratios. The sine would technically be x over 1, and then the cosine would be the square root of 1 minus x squared over 1. We typically omit the 1s when we do this. All right? So we've got cosine of theta. Cosine of theta is the square root of 1 minus x squared times cosine of phi. Cosine of phi is y. And then we have sine of theta. Sine of theta is x. And then sine of phi. Sine of phi is the square root of 1 minus y squared. I like to simplify this a little bit. Just get rid of the parentheses. And that's about it. That would be your answer. So the answer is y times the square root of 1 minus x squared and minus x times the square root of 1 minus y squared. We're going to talk more about inverse functions in the next couple sections. That was just to kind of get it out there that inverse functions are a way of rewriting an angle, or evaluating what the actual angle is. If I wanted to actually know how many degrees theta and phi were, I could, solve for them in a future section. So this is just kind of getting that out there for you so that you have that capability. The next example is to rewrite y equals 3 sine x plus 3 radical 3 cosine x in the form y equals k sine x plus phi. So it's just taking the formula that we already knew about adding sums of sines and cosines. So we have the sum of this, x plus phi. And I want to be able to go the other way. I want to write from this into this. Okay. So by the sum formula for sine, we have sine of x plus phi is equal to sine x cosine phi plus cosine x sine phi. Yeah, that's just reviewing the sum formula for sine. So k sine x plus phi is k sine x cosine phi plus k cosine x sine phi. Just distributing the k to each of the terms in the sum formula. Look at what we have. This is what we're given. Sine x and cosine x. So we need to solve for k and phi. And so we're just going to set these equal to each other. And solve. I'm running out of space, so I'll get to that in a second. So we're going to set these equal to each other. So I've got y equals this, 3 sine x plus 3 root 3 cosine x. And then I've got this one here, y equals, all of this is y. Y equals k sine x cosine phi plus k cosine x sine phi, and I'm going to set these equal to each other. So 3 sine x plus 3 radical 3 cosine x must be equal to, now watch how I rewrite this, k cosine phi sine x. So I want these to be in the same order, plus k sine phi cosine x. So I'm just moving the cosine and the sine so that I can set these parts equal to each other. 3 must be equal to k cosine phi, and 3 radical 3 must be equal to k sine phi. In other words, this is one of the oldest tricks in the book. You take two equations, you set them equal to each other, and then you separate them into 2 separate equations. This equation involves the cosine, and this one involves the sine. Okay. I don't care about what x is. I only care about solving for phi and for k. We're not solving for x. Okay, let's go ahead and solve this. What do we got? Let's put these together. So we have k sine phi over k cosine phi is equal to 3 over 3 square root of 3. So k over k times tangent of phi is equal to 3 over 3 square root of 3. And we're going to cancel the k's and cancel the 3's. Don't forget to put a 1 in the numerator if you cancel. Technically, this becomes a 1 also. The k divided by k also becomes a 1. If you forget to put the 1 in front of the tangent, it doesn't matter. That one's forgivable. But if you forget to put the 1 over here, it's going to be incorrect. So now we have tangent of phi is 1 over square root of 3. So in other words, what angle phi is tangent equal to 1 over square root of 3? You can use your calculator or use special triangles, whichever you prefer. For this particular one, I like to use a special triangle. That square root of 3 is down here, 1 and 2. This is 30 degrees. So phi is 30 degrees, or in radians, pi over 6. If you use your calculator, phi would be tan inverse of 1 over square root of 3. So you use your tan inverse button, which is a second function, tan inverse. You get phi is approximately 0.52359, etc., etc. This is an approximation, and this is an exact value. So read carefully. Sometimes I say, you must give me an exact value, then it's pi over 6. If I say an approximation, then 0.52359, or I would probably go to 0.5236, because I typically like 4 decimal places. Either way, these are both correct values for phi. Just make sure you read the directions carefully. Okay? So we've got our phi. Now we got to figure out what k is. Notice that k canceled out, so it's not very easy to find k anymore. But we do have that k cosine phi was equal to 3, and k sine phi was equal to 3 root 3. So we could solve this by using the Pythagorean identity. We just add them up and square them. Let me say that again. Square them and then add them up. And we're going to get 3 squared plus 3 root 3 squared. Use the Pythagorean identity. Pythagorean identity. I better write this down here. We'll keep the exact answer, and I'll erase my approximation. So we have k squared cos squared plus k squared sine squared equals 9 plus 9 times 3, or 27. So the right-hand side is going to come out to be 36. We can factor out a k squared, use the Pythagorean identity. Cosine squared plus sine squared is equal to 1. So k squared is equal to 36. So k is 6. So put these together. You've got your phi and you've got your k. So put this all together to get our answer. Y equals 3 sine x plus 3 radical 3 cosine x transforms into k sine x plus phi, which is 6 sine x plus pi over 6. So this function is your answer of how to rewrite two trig functions, or the sum of two trig functions using the formula for sums, into one trig function, in particular sine of x plus phi. What's really useful about this is what the graph looks like. It essentially tells me that I'm taking a sine graph of amplitude 6 with a shift left pi over 6. What would that be? That would be 11 pi over 6. It's not a very good graph. I could probably do better, but it's just to give you the idea. This graph here, y equals 6 sine x plus pi over 6, has an amplitude of 6. That's your amplitude. And then it's been shifted left, negative pi over 6. And so that's the significance of the k and the phi. The phi is telling you the way it's been shifted. If it's positive, it shifts left. And if it's negative, it shifts right. And the 6 is telling you the amplitude of the function. It's much easier to graph one trig function than it is to try to graph two. This would have taken you much longer to try to graph the sum of these two trig functions. Okay, that concludes 7.2. So that's it for today. We're a relatively short lecture today. We'll start 7.3 tomorrow.